Hello, welcome to my series on computer science and computer science integration pedagogies. My name is Yu Hongsun. I'm one of the MLTI 2.0 ambassadors. My job is to work closely with the Moodle digital learning specialists and the other MLTI 2.0 ambassadors to provide instructional technology coaching, create and deliver professional learning. This is me in my Bitmoji. I'm very excited that you could join me in exploring some of the effective pedagogies in teaching computer science and integrating computer technology into K-12 curriculum. Over the past decades, there has been an increasing research on computer science and computer science integration pedagogies in K-12 education. Data shows that certain teaching methods are more effective than others for computer science and computer science integration. The theories will explore the popular pedagogies for computer science and computer science integration, such as computational thinking, contextualized learning, collaborative learning, and learning away from the computer. The series will use examples from the teachers of computer science and other disciplines and discuss which teaching methods and pedagogical approaches are effectively used in the classroom and how the teaching methods support the learning processes and prepare students for the 21st century job market. Here are the topics. Topic 1, Computational thinking skills development. Topic 2, engaging students through contextualized learning. Topic 3, building critical thinking and problem-solving skills through collaborative learning. Topic 4, cultivating computer science and computational thinking skills by teaching away from the computer. Today's topic is computational thinking skills development. It will cover what is computer science, what is computational thinking, importance of computational thinking in K-12 education, influence of the computational thinking in the K-12 education, how to prepare teachers to teach computational thinking skills, how to build students' computational thinking competence. What are the effective teaching methods and strategies to teach computational thinking? What is computer science? The study of computers, including computational theory, principles, algorithm, hardware and software designs, implementation, and the way humans interact with computers. The most important aspect of computer science is problem solving. It is an essential skill for life. Therefore, the study of computer science will help students to develop problem-solving ability, to improve planning, designing, and analyzing skills, to build the skills to solve problems in almost every industry, and to enhance preparedness for the 21st century job market. From the definition, we can see that computer science is not just programming nor computer literacy. Computer science is the study of how to apply computational process to solve problems that happen in our everyday life and involve many other disciplines. Based on Dr. Porkvik, a professor at DuPont University, a student needs to acquire the following skills. First, computer literacy, which is the ability to use basic computer applications such as Word, spreadsheet, web browser to perform a task. Second, computer fluency, which consists in a high-level understanding of how a computer system works. Third, computational thinking, which is needed to apply computational techniques in every field, according to Dr. Wing in 2006. But in the past decades, computer science is often taught in K-12 schools as computer literacy, the ability to use technology, mostly to teach students to become consumers of technology, not creators of computer. What we really need is to teach conceptual skills and problem-solving skills besides computer literacy. As we know, software and operating systems evolve very quickly. Before students graduate from schools, the software or the apps they have learned in schools have become obsolete. So that is why computational thinking has been proposed to address this issue by Dr. Wing in 2006. What is computational thinking? According to Dr. Wing, computational thinking is a thought process involved formulating a problem and expressing its solutions in such a way that a computer, human, or machine can effectively carry out. It is a fundamental skill for everyone, not just for computer scientists. To reading, writing, and arithmetic, we should add computational thinking to every child's analytical ability. To understand the definition, there are three concepts. First, it is a thought process to understand and solve complex problems through using computer science concepts and techniques. Second, it is a fundamental skill for everyone in all industry. Third, it is a fundamental ability that every child should develop. Computational thinking fundamentals. The fundamentals of computational thinking consists of decomposition, abstraction, algorithm, pattern recognition, logical reasoning, and evaluation. Decomposition, it means breaking down a complex problem or system into smaller parts that are more manageable and easier to understand. The smaller parts can then be examined and solved, or designed individually as they are simpler to work with. Abstraction, it means filtering out, essentially ignoring the characteristics that we don't need in order to concentrate on those that we do. Algorithm, it is a set of well-defined instructions to solve a particular problem. Pattern recognition, this is the process of looking for similarities across sets of problems or similarities within the problem itself. Pattern recognition can be applied to the solution as well. Logical reasoning, it means making decisions, doing one thing or another. Evaluation, this is a process by which a computer system's resources and outputs are assessed to determine whether the system is performing at an optimal level. Seymour Papert was the first to promote computational thinking in schools in the 1980s. He stated that students could develop procedural thinking through programming. It was Jeanette Wing who reignited the interest of computational thinking and popularized the idea in an article she published in 2006 in the magazine of the Leading Society of Computer Scientists. In this article, she argued that computational thinking skills are fundamental for all students to learn in all subject areas. Wing argued computational thinking is a basic skill for all humans, not just computer scientists. It is a key skill for the workforce of the 21st century. In 2006, Wynne said, "Since computational thinking is for all disciplines, and it will influence all the disciplines," she predicted that college students from non-computer science majors would flock to take computer science classes. She argued that students who learn computer science concepts can take them to wherever they go, whatever professions they pursue, and whatever majors they are interested in. Since then, computational thinking has been the subject of intense and long discussions within the computer science education community. The discussion has been that computational thinking should be taught everywhere, especially at the school level. In the center of discussions are the questions about the importance of computational thinking and also how this important skill can be effectively taught in K-12 schools. In 2016, 10 years of Wynne introducing computational thinking, she said that she didn't expect that computational thinking has generated such an interest in schools that it has become pervasive in K-12 education, not only in America, but in the world. In the past decades, computational thinking has become one of the driving factors in the reform of the K-12 education. Many countries face rapid changes in the K-12 curriculum in order to integrate computational thinking as part of the 21st century skills. Many countries began to introduce computing, programming, digital competencies in elementary schools, and to build more advanced courses on computer science and its impact on society in secondary schools. Let's take a quick look at how other countries have incorporated computational thinking in their curriculum. Australia. In 2015, Australia incorporated both digital technologies and design and technology in their curriculum. Within digital technologies, children build computational thinking skills and learn about data, digital systems, and how to implement solutions with programming. It is a subject of its own. Finland. In 2016, Finland increased the focus on digital competence by integrating computer technology in all grades, including programming in primary education. South Korea. South Korea started computer education in 1971. In 2007, informatics was in their national curriculum, and the main focus has been on computer science principles and concepts. United Kingdom. In the United Kingdom, the transition to more programming in school started in 2012. In 2014, computing as a new subject was introduced to replace the ICT in curriculum. It contains computer science, information technology, and digital literacy. They said every child should have the opportunity to learn concepts and principles from computing, including computer science and information technology from primary to secondary school. Poland. In Poland, computer science has been a subject in the secondary education since the second half of the 1960s. In 1990s, the first national curriculum was introduced. In the proposal, computer science is a compulsory subject in all grades. Sweden. In 2018, Sweden started to introduce programming in primary school and to increase the access to programming and computer science in secondary school. The focus is to strengthen students' digital competence and to strengthen critical thinking and problem-solving skills. In order to compete with other countries for the global job market, America has made great efforts to push computer science and computational thinking into a national level curriculum. Even though the education system in the United States is highly decentralized, and each state and school district has its own curriculum, there has been a joint effort to promote computer science and computational thinking for K-12 education. For example, Association for Computing Machinery, ACM, Computer Science Teachers Association, CSTA, Code.org, and the National Math and Science Initiative, NMSI, to name just a few. Those organizations are all involved in computer science education in order to develop a framework for K-12 computer science education. The questions they ask are, what should all students know and be able to do in K-12 computer science? What does the community expect every student to learn in elementary school, in middle school, or in high school, and why? In 2016, President Obama announced a $4 billion Computer Science for All educational plan to provide a foundational learning to benefit every child. He said that in the new economy, computer science isn't an optional skill. It's a basic skill, right along with the 3 R's, which is reading, writing, and arithmetic. The belief is that every child should have a chance to learn about computer science in order to prepare for the 21st century job market. And in 2016, the College Board launched a new computer science curriculum for high school students. It is called Computer Science Principles. The focus is to expose students to computational thinking to help them understand how computing works and how it influences our lives. As we can see, that America has made a substantial progress in promoting computer science and computational thinking in schools, but there is still a long way to go. Computer science and computational thinking are the familiar terms in the computer science education community, but not quite in K-12 schools. Many teachers and administrators have preconceptions or even misconceptions about computer science and computational thinking. The common misconception is that computer science is about how to use computer technology, while computational thinking is for computer scientists. The reason is clear. It is an unbalance between the fast-growing demand and the rapid changes in computational thinking as fundamental skills in schools and workplaces, and the slowing keeping up teachers with the relevant knowledge and skills to prepare students for the future career. There is a shortage in teachers with experience and knowledge in computing area. Those are the challenges that we are facing. The urgent questions we ask are how to educate teachers fast enough to provide them with applicable concepts and knowledge, how to add the content of computational thinking to the existing pre-service educational program to equip teachers with the relevant competence and skills, how to develop more efficient in-service training programs to support teachers over time by providing them with the teaching materials and the teaching methods on a regular basis. It is important to have not only pre-service educational programs, but also in-service professional training to prepare teachers to support students' understanding of computational thinking concepts and their practices in all subject areas. This is what MLTI 2.0 is offering. MLTI 2.0 refers to the Main Learning Technology Initiative 2.0. It is a program within Main DOE's Office of Innovation. MLTI 2.0 delivers a state-level technology program to schools. One of the MLTI 2.0's program components is professional learning. Currently, there are 9 MLTI ambassadors working directly with teachers in the field to provide instructional coaching and professional learning. Paired with that, we also provide ongoing asynchronous training in computer science and computer science integration. We cover a wide range of topics such as digital citizenship, effective technology integration, blended learning, computational thinking and engineering, gamification, problem-based learning, to name just a few. Those videos provide teachers with the knowledge, pedagogy, and instructional strategies you need to integrate computational thinking into your curriculum in meaningful ways so that you can engage your students to use those concepts and skills to solve problems. We also introduce bite-sized tools and materials on a regular basis for you to evaluate and select the right one for your lesson plans and teaching practices. In September, Governor Mills announced the launch of a new Maine Department of Education initiative that will provide every Maine public school with a free mobile computer science lab. The effort will enable all Maine students to have real-world learning experiences in robotics and programming, augmented and virtual reality, and coding and hardware. Just recently, Maine DOE announced the launch of Phase 2 of the Maine Teachers CS initiative. This initiative is to train the trainer to support teachers in integrating computer science into their curriculum through the mobile labs. As an MLTI 2.0 ambassador and a computer science teacher, I would love to share my teaching methods as how to build students' computational thinking skills from my 18 years of teaching experience. Building students' computational thinking skills requires practical teaching methods. We begin with a set of questions that focus on K-12 classrooms. What would computational thinking look like in the classroom? What should students know and be able to do? What would a teacher need to teach computational thinking? What are the examples to integrate computational thinking in other subjects? What are the effective teaching methods and strategies to teach computational thinking? I will discuss those questions in my next 3 videos, and I will explore the teaching methods and strategies for teaching computer science and computational thinking. My next video will focus on how to embed contextualized learning in teaching computational thinking to engage students. I will explore robotics, scaffolding, animation, and games as effective approaches in contextualized learning. My third video will concentrate on how to build students' computational thinking through collaborative learning. I will explore peer review, pair programming, group work, learning by teaching, problem-based, and project-based learning. My fourth video will explore teaching away from the computer, or CS Unplugged. CS Unplugged is a comparatively new approach to teach computer science concepts without using a computer. It has become a popular strategy to teach younger kids computational thinking by making lessons more engaging and fun. I will use examples from the teachers of computer science, math, English, music, social studies to see how they use unplugged activities to engage students to understand computer science and computational thinking through hands-on activities, puzzles, games to solve problems. Thank you for watching my video. Look forward to seeing you again on December 6th.